Greetings and salutations. Beautiful day for a webinar. How are you, Murray?
Bloody brilliant, mate.
Very good to hear. Look, we'll give people an opportunity to come through the virtual turnstiles, but thanks for everyone who's joined us already. Another super popular Ocean Protect Stormwater Fundamentals webinar, and it's no surprise when you've got the esteemed Murray Powell Esquire gracing us with his presence. But look, before we dive into Murray's presentation and just give people a chance to come through, just a reminder, folks, this is number 6 of the Stormwater Fundamentals series, happening every month, all free, all amazing. And the next one's in July. And that's me presenting, would you believe? Heaven forbid. If you like webinars, and I'm sure you do, we've got another one. This is actually an Australian Water School webinar happening, gee whiz, next week. Myself and Dr. Carl Bowles from Jacobs will be presenting. So if you're keen to register or find out more about that one, just tune in there. I'm not sure if you can hear much noise in the background, Murray. I got a drill in my ear. So hopefully my noise cancelling headset's working a treat. If it is, fantastic.
Mate, we're all good at this end.
Oh, there you go. I can't hear a thing. But again, if you like the in-person events, we've got one of those as well happening in August. And would you believe Murray Powell's going to have a Guernsey on that one? So it's all about bioretention systems. So if you're keen to find out more, it's a low price for an in-person event. It's at William Inglis. It includes a whole bunch of presenters: Craig Bush, Mark Liebman, Nicole Woolwood from Water New South Wales, and a tour of some nearby bioretention systems in Western Sydney. So if you're keen to come along, and who wouldn't, be sure to jump on the website there, oceanprotect.com.au/events. Obviously, if you love a podcast, and Murray's been on a couple of times, feel free to dive in. We had couple of really good podcasts of late. Everywhere we listen to podcasts, and from a Queensland perspective, and this is where I'm calling from, we've actually moved, just as FYI, from our facility in Loganholme to a facility in Stapleton, which basically has increased our capacity enormously. We can now, Ocean Protect can now make precast components for detention tanks, manholes, so for all our pre-treatment components like Stormfilter and Jellyfish and Ocean Save, and we make Urban Pond, and we've actually done quite a few Urban Ponds already. So if you're not familiar with Urban Pond, it's basically a detention system, very easy to install. A lot of advantages, a lot of benefits, and if you're keen to find out more, just jump on that website there. These are a couple of 3 installations just literally in the last few weeks in and around Queensland, Ripley, Augustine Heights and Harvey Bay. So if you're keen to find out more, just give us a shout. And just a reminder, folks, if you're new to the webinar scene, if you've got any questions, please put them in the Q&A panel. Chat. If you put any comments and whatever in the chat, that's great, but it makes it a lot easier to handle or manage the questions if you put it in the Q&A panel. And just a reminder, the slides and the recording will be made available on our Ocean Protect website, just oceanprotect.com.au/webinars. Give us a day or two, and Murray's dulcet tones will be on there again. And again, if you've got CPD form requests, and we get a lot of these, if you've already requested one, it'll probably be in your inbox in about a week's time. You would have actually nominated whether you want a CPD in your registration or not. But if you don't receive it, just email us at marketing@oceanprotect.com.au. Cool. But without further ado, we're going to give the floor to Murray Powell Esquire. So Murray, you're welcome to share your screen if you like, whilst I give you a glowing introduction. So Murray Powell is the owner of some of the worst shirts the stormwater industry has ever seen. A lot of fish-themed shirts. He likes to surprise me with how bad they are each time. No, but in all seriousness, separate to male modelling. Oh, look at that. There's
more fish than you can make a stick out.
There's a distinct lack of bench pressing going on in Murray Powell's home gym. But that aside, we don't love Murray for his shirt or fashion. We love him because he's a fountain of knowledge of all things stormwater. He is the general manager of Optimal Stormwater. He's a national treasure and a treasure to our stormwater industry. And if there's anything he doesn't know about GPTs, it's probably not worth knowing about. But he's also a guru when it comes to secondary stormwater treatment assets. And that's what he's going to talk about today. So Murray presented on primary stormwater treatment assets last month. but he's following this up with a sequel. So Murray, the floor is yours. If you want to share your screen.
It's saying your screen sharing is paused.
Oh,
What is
I
it
tell you
doing?
what, I'm going to stop sharing my screen and just, oh, here we go. It should be okay now, Murray, I think. Do you want to just click the start button, maybe? Let me just see if I'm blocking anything from my end. Is it okay? Here we go. Oh, sorry. If you share now, Murray, should be okay. Just try that again, maybe. Because it might have just been blocking because I had my little screen up before. There we go. So
Screen sharing. All right.
So you might want to just scoop on back. Is that the start, Murray? I can't remember.
No, that's not starting. It's a couple of slides in. There we go.
Cool. Well,
G'day
again,
all.
just folks, if you've got any questions, feel free to put them in the Q&A. First in, best dressed. But I'll leave the audience to Murray Powell's pearls of wisdom.
Thanks, mate. So obviously, this is part 2. We looked at primary treatment a month or so ago, and having had a look at the people that are attending today, I realise I know many of you, so g'day all, and special shout out to my mates in Tassie. We're today looking at secondary treatment. Obviously, it's the second part of your stormwater treatment train. This is sort of high level, it's basic, it's fundamentals. We're not going into the full detailed design of any of these elements, but there's going to be a lot of great stuff that you'll learn. Without further ado, quick recap. Obviously, when you're looking at a stormwater treatment train, which is the best way we should do it, it starts with prevention and source control. Then we've looked at the primary treatment to remove all the large items that you don't want to get into your secondary treatment. And the way I view it is tertiary treatment is obviously the disinfection, reuse, and stormwater harvesting that can potentially follow. Your primary treatment is predominantly aimed at anthropogenic materials, your litter, etc., as well as the larger organic load, specifically leaves, a lot of grass clippings, etc., weed seeds, and you know the rest. And then obviously the coarse and some of the finer, coarse and medium sediments. That's what your GPTs and things are supposed to do. Typically, as a breakdown by volume or by mass, it's about 10%, litter, and 60-70% organics, and the rest sediment. Now we're getting into secondary treatment. This is aimed specifically at your fines. It's the finer component of your sediment range, the silts and clays. It's looking at the organics, the grass clippings and leaves that get broken up under the car tires, and they come through as 1 and 2 mil and smaller particles. Heavy metals from brake dust, other industrial sources, plenty of ways to get heavy metals into our stormwater. Added to that, pesticides, chemicals, fertilizers. There's a range of those that get in from time to time and cause problems. Nutrients are certainly a large one and can contribute to eutrophication and algal blooms and other problems. And of course, then the soluble one, if you like, bacteria, which obviously impacts our ability to swim in our waterways and contact it, and can create issues for your bird life and everything else that's living around your wetlands and things. So the technologies, when we did the primary treatment, we looked at the 5 different technologies that there were. There's largely 2 when it comes to secondary treatment. Sedimentation is the first one. This is predominantly where flows come in and you've got a wetland or a pond or something. We'll talk about it more in a minute, but you're capturing pollution because it's settling to the bottom of a wet system. The next one is filtration. When we talk about gross pollutant traps, we're talking about screening. Filtration is a media. It's got density and mass to it, and a much slower, tortuous flow path for the pollution to actually try and get through along with the water. But you also have natural biological reactions. Biota and microbes and things will all consume hydrocarbons and organics and things. They'll also address things like nitrogen. So you might have a nitrate, NOx, that will be biologically degraded down and produce nitrogen gas. So you can actually address some of your soluble and particulate pollutants biologically. Adsorption is when things attach to the outside of a particle. A lot of chemicals, a lot of fertilizers, a lot of heavy metals, etc., they adsorb to the outside of fine silts and clays and things. Absorption is different. It gets absorbed into the mass or the item itself. Typically, where we're talking about nutrients and carbon, etc., being absorbed into plant mass. Then there's biological decay, and we'll talk about that a bit more in a minute, where you've got organics, being carbon, hydrogen, and oxygen. There's your C and H and O, producing predominantly carbon dioxide and H2O being water, but it's in a vapor form. So it's both of them just disappear. And of course, then you've got bacterial die-off under the great big UV reactor that we call the sun. It's not as effective as a UV in a stormwater treatment system or a sewer mining system, etc. However, it does have a positive impact and will address bacteria. So, who loves chemistry? My first degree is in chemical engineering, so I'm sorry about that. If I start going over your head, just tune out, but I'm sure you'll be right. Natural decay of organics, which are predominantly made of carbon, hydrogen, and oxygen, will occur either in aerobic conditions or anaerobic. If it's in the air, it's aerobic. If it's underwater and it consumes the oxygen, it will be anaerobic. So what actually happens? Where do we get the oxygen from? If I go back a slide here, you can see this is not a proper chemical formula. So please don't crucify me over this. But you can see on the left, we've got one oxygen. And when we get to the right-hand side of that equation, there's 3 oxygens, CO2 and the H2O. We need more oxygen for this reaction, this natural decay process to happen. The first area that they'll get oxygen from is the dissolved oxygen that's within the water. The next thing is, once you've started getting really low on that dissolved oxygen, it'll start getting into the sediments and taking things like PO4 is a phosphate and a common element in fertilizers, etc. It will disassociate the phosphorus from the oxygen. The oxygen goes into the decay process, leaving you with bioavailable phosphorus, which of course then potentially leads to your algal blooms and things. Nitrite and nitrate, same thing. It'll strip out the oxygens, leaving you with nitrogen, or sending it from nitrogen, from an inert nitrite into something more sinister like ammonia, which is actually a poison. A lot of you are probably going, what's Fe2O3? Well, Fe is the symbol for iron, O is the symbol for oxygen, iron oxide. A lot of you would know it as rust. Where do you get it from? Everything that's rusting in our catchments. Corrugated iron roofs and gal steel that hasn't lasted, etc., etc. Plenty of sources for that. They strip off the oxygen and you're now left with soluble metals in solution. And of course, this is a specific example. H2SO4, some of you will go, oh, I know what that is. It's actually sulfuric acid. Where might one find sulfuric acid? In your car battery would be a good place to start looking. So if 2 cars go bang, batteries uprooted, H2SO4 gets into the stormwater. It takes the O4, and you're left with H2S. H2S, of course, is better known as rotten egg gas, and it can stink. In low concentrations, it's odorous and offensive. In high concentrations, it's poisonous and will kill you. So anaerobic breakdown will happen. It's a natural decaying process. And what that produces is very low dissolved oxygen levels in your wet systems. And what plant species likes low dissolved oxygen? And the unfortunate answer is algae. Righto. But when we're looking at the different treatment types, we'll start with sedimentation. Items heavier than water, i.e. silt, sediments, gravel, etc., will tend to sink to the bottom. This isn't rocket science. Common techniques, of course, are your sedimentation basins, more associated with construction stage, ponds where you don't have a lot in the way of macrophytes and vegetation, On-site detention tanks, when you start getting the maxi-mesh screen on the back blocked and they pool water in there, everything will start settling inside your OSD tanks. Detention basins above ground, etc. They're designed to slow water. When you slow water, stuff will settle out. It's sedimentation. And then, of course, you've got wetlands, which are designed specifically to allow the silt and clays and other adsorbed pollutants to be captured. When we look at filtration, the next type of treatment, you're talking about the flow going through some form of media. I'll talk more about that in a minute, but common examples are swales. Massive fan of grass swales, done well and nicely mowed, etc. Biofiltration and bioretention, essentially the same thing. And we've got to talk more about that in a minute. Rain gardens and tree pits obviously are essentially just smaller versions of biofiltration. Then we get into media cartridge devices. Obviously, you can put different media in there to target different types of pollutants. If you're specifically looking to strip out nitrogen or phosphorus, etc., you'd particularly use different media mixes. Feel free to talk to Brad about that. They've got a whole bunch of things that can target certain types of pollution. Porous pavers is another media. It's a fixed media. Flow is designed to go in, flow down through the paver itself, and we'll talk about that in a sec. Upflow filters is essentially a porous paver where the flow's going in the opposite direction. The theory is when the flow's going up, stuff that gets caught on the underside will slough off between storm events. That will work for things like leaves, but there are other things it does not work for. Talk about that in a minute. Jellyfish cartridge, that's a membrane, not a media, but it looks to achieve a similar sort of outcome where flows are going in from the sides. But the most common of all the filtration techniques by a country mile is your biofiltration. So we get back to our treatment technologies. Sedimentation number one, filtration number two. Natural biological reactions are happening when you've got a wet zone for those to occur, predominantly in the sedimentation area. Adsorption to fine particulates, you'll get it in both of the, and the next one, absorption, you'll get it in both sedimentation and filtration systems. Sedimentation predominantly wetlands and ponds and things, filtration predominantly biofiltration. Biological decay, you will get happening predominantly in sedimentation. And then bacterial die-off, again, is predominantly in sedimentation. So let's have a look at some of the differences between these two techniques. And it's quite important that you understand the difference between them, because a lot of people haven't really thought about, why should I use a bio or why should I use a wetland? Well, the primary treatment technique in wetlands is sedimentation, and in bioretention, you're talking about filtration. Flow comes in the slide you can see here from the left-hand side, and in the wetland, there is nothing impeding the flow. So hydraulically, the flow comes in and goes slowly across the wetland itself, and then will eventually overtop and leave at the other end. While it slows the flow, particles, etc., can settle out. The great thing about it is it doesn't block the flow path. So hydraulically, they keep working. The problem with your biofiltration is not that it's really high performance, is that depending on the pollution type and load, it can coat the surface. And you end up with a coating of leaves and grass clippings or silt and sediment, etc. And the flow is supposed to go down through the media into the subsurface collection pipe and leave. The problem is it blocks on the top of the filter and then will overtop and bypass treatment. One has good hydraulics, the other has not as good hydraulics. Important to understand the differences. Okay, let's talk a bit more about bioretention. Currently, if you're using music, and I'm sure most of you are, it's got the highest theoretical removal rates of any of your secondary green technologies you like, not the proprietary stuff, the bio and wetlands. It's used extensively, certainly in Queensland and Victoria, a little less in New South Wales, Tas and SA. Don't know why that is. They do use it in those other places, just not as much as in Queensland and Victoria. Developers certainly like it because it takes up a lot less land, therefore you get more lot yield. Therefore, developers make more money if they put in a smaller treatment system. Historical failure rates, and I've heard this from multiple people, and I've experienced it with auditing hundreds of these systems. Approximately 80% of them are not working anywhere near what they should when we come and do the auditing. Lots of reasons behind that. Talk more about that in a sec. Newer solutions are obviously better than the older ones. We learn as we evolve as an industry. But the performance of your bio and how well it works will come down to number one. Well, it's not number one, it's number two. Number two is pre-treatment of your system. If you can take out 90% of the load before it gets there, your bio's got a really good chance. Second thing is the type of pollution. If you're getting paints and oils and fine silts and stuff that's just going to clog the top, it's going to have a lot less chance of surviving properly. The load of pollution comes back to pre-treatment. If you don't pre-treat it, the load of pollution can just coat it. You can have a whole bio, non-operational in half an hour if someone's, emptied a grass catcher full of leaves and it's just coating the surface, depending on size, etc. The type of media. Now, you could use sand, you can use Forb media, etc. Ocean Protect has their Filtration media, which I'm told is very good, and I've got no reason to doubt it. But if it's blocking on the surface, it's not getting into the media as well as it should. But obviously, the more high performance your media, the better result. The number one thing that's going to influence those bios and their performance, though, is the cleaning regime. That's assuming it's been constructed correctly and it's actually working. How often you clean it. Righto. Poor pre-treatment or no treatment has been a big limitation in the past in a lot of cases, continues to be so in some. Very poor understanding of hydraulics in relation to pre-treatment. A lot of people, consultants, design systems where you've got the level of the bio downstream matches the invert of the outcoming pipe. So the flow comes in from your outcoming pipe and builds up. And as it builds up, it puts a hydraulic backwater onto your GPT, stopping it from working. All the pollution bypasses, ends up wrecking your bio because the hydraulics were wrong. Poor construction, lots of instances where construction contractors have taken shortcuts and people haven't realised because it's all buried underground. Swapping good media for lesser media, that's historically been an issue. It's less of an issue now, but still remains that way. Media used to have very, very low levels of organics in it. And the organics, apart from providing a food source for the plants that you're growing in it, they also help to retain the moisture and the water in the soil so the plants can actually grow. If you go and plant your lamandra bush in the middle of Manly Beach, it's not going to last long. It's going to dry out and die. So you do need to have a certain degree of organics, and we've learned over time you need more organics than we originally thought. And Forbes Spec and others have realised this, and we've learned and changed and evolved, so that's good. I've seen it several times where these things are built during the construction phase, and as a result, they're getting covered with sediment and clay and things during the construction phase, and then they're just not working. So basically, the first step when you're ready to hand it over is to reconstruct the entire thing. I'm a bit of a fan of constructing it, but not filling it, and using it as a sedimentation basin. If you do have to construct it, you're better off sort of covering it with something and allowing stuff to deposit on it, but without wrecking all your media. Anyway, the construction phase and biofiltration seem to be mortal enemies. Slotted pipe is another thing that can be done right, or it can be done dodgy. You can actually buy a standard piece of pipe for a fraction of the price and just get out your circular saw and go, put a few holes in it. Of course, how many holes? How long? How wide? If you put too many, the whole thing can just collapse. If you don't put enough, the water can't get in. So the last 3 contractors I've said, oh, did you buy slotted pipe, or did you just buy standard pipe and put your own slots in it? All 3 said, oh, no, we just bought our own pipe and put slots in it. So maybe there needs to be a spec on how to do that if that's the way it's going to be done. Poor water distribution across bio is a big failing and still continues to be a challenge for designers. Lack of cleaning, obviously leading to weeds, litter, bypassing of the pollution, etc., has historically been one of the biggest challenges. And then some are very over-engineered and very ugly. Our landscape is littered with really shit designed bios. There are some lovely examples, and we're going to see a couple in a sec, but geez, there's some ugly stuff that's been done in the past. But happy days, things are improving, we are learning, we are evolving. Righto, let's talk wetlands. Having done a lot of auditing of your WSUD type or secondary treatment solutions, I can proudly say that approximately 80% of the wetlands we find, maybe even 90%, are working well. Some are working excellently, some are working not 100%, but they're good enough. But as opposed to bio, the success rate in wetlands is significantly higher. New South Wales and Queensland tend to have more pre-treatment. There's less pre-treatment down in Victoria from historical policies by Melbourne Water, etc. But you know, they're on the ball, they're on the bandwagon, they're understanding, they're looking at all their wetlands now. Wetlands are hydraulically reliable because there's nothing to block. So the water comes in, gets treated, and leaves. It's not like a bio where it blocks the surface and just bypasses and leaves. So you're getting more water treated, potentially to a lower standard. Anyway, wetlands themselves, though, I know a couple of very lovely wetland designers that specialise in this field, and they're all about amenity, biology, biodiversity, the ecology, place setting. You know, put a track around the wetland and allow kids to ride their bikes around it. You know, these things have value. Obviously, they're improving property prices if you're near a nice waterway, even if it's just to, you know, go down, sit there, have a picnic and look at the ducks. Benefits with urban cooling, habitat, biodiversity, as I mentioned. You can get algal blooms, of course. Now, there's a lot of ways of addressing those. Not going to go into that today, but needless to say, it is a problem, but there are ways of controlling it and ways of minimizing that it can help. It will actually happen. Number one, start with good pre-treatment. Obviously, when these things started getting designed, the wetland standard back in the 1970s, yes, I was around the 70s. God, I was even here in the bloody late 60s. But I was very young then, let's just say. But this standard used to be sizing for a 14-day residence time on the assumption that you would be removing 70% of the nutrients. The design standard back then was called the Lawrence curves. 30 years later, Ian Lawrence came out and he tested half a dozen or a dozen or 2 dozen, I can't remember now, of the wetlands that he had designed. And I think 2/3 of them were still having a very slight positive impact, and the other third were producing more pollution than they were removing. Predominantly, they didn't get any maintenance and there was no pre-treatment. So old design standards are gone. We know more about pre-treatment, about maintenance, and about removal efficiencies. But the old standard used to be an assumption of 70%. Okay. One thing you should know about wetlands is that the community tend to love them. They will go around and pick up litter around them, etc. They like to have a look at the skinks and lizards and dragonflies, etc. The community values those waterways once you build them for it. So if you build a wetland and you don't pre-treat it to take out all the litter and rubbish, they're not going to be happy with it, because they start seeing it not as a stormwater treatment solution, but as part of the environment that should be protected, even though it actually serves both purposes. Okay, a couple of quick things. Comparison between bio and wetlands, if you like. Bio tends to block. It'll bypass once it's blocked. You get decaying treatable flow rates through the media. Historic poor performance. Storing pollution in the media means periodically you've got to change the media. These are harder to clean. You've got to take plants out to pull media out, etc. They can be beautiful or they can be ugly. But you do need to look at cleaning them quite regularly. And Music says they are the best of the secondary treatment systems regarding performance. Wetlands, on the other hand, they're actually non-blocking. They're very reliable. They're a lot less maintenance intensive. They typically store pollution offline on the base of your pond or wetland, etc. So it's not in the direct flow path. You've got benefits of biology, ecology, aesthetics, etc. Place setting, urban cooling, attracting and retaining wildlife, increasing property values. But Music if you're looking at just a technical performance thing, says it's not as good as your bio. Developers love bio simply because it's taking up a physically smaller area, therefore they can sell another couple of lots. Generally, you want to protect these during the construction phase. You may need watering to keep the plants going on these things too. If you don't already know, when you first build a bio, the organics and stuff that are part of the media can actually contribute to pollution. They're certainly more costly to reset and easier on paper. But wetlands, in turn, you can actually start them as a sedimentation basin, convert them into a wetland. They're going to be a permanent body of water, and the community is going to love them. So what you'll find is that bioretention works better for developers, and wetlands sort of works better for the councils and the community. Historically, a lot of failure in bio, a lot less failure in wetlands. So music says yes to bio, but Murray says yes to wetlands. So given the choice, I would design a wetland over a bio every day of the week, but I have designed several bios and we've seen some work and some fail. All right, just a couple quick photos here. The photo on the left is a small bioretention / rain garden at the bottom of a car park. It actually worked reasonably well. It's got even thicker vegetation through it now. It's easy to clean out the litter, etc. There's not a lot of sediment and stuff getting into it, and it's working well. The wetland on the right, probably a little bit much in the way of floating waterweed and things growing in the wetland, but it's actually very beautiful. I love that photo. And that's courtesy of Brad Dalrymple. Here's another photo, courtesy of Brad Dalrymple on the left. It's a bio system. That one's using Filtration media. I particularly like the plants. Brad will be able to tell you later what those plants are. The ones with the little wafty things on the top. Stunning. They look great. And it's functioning well. On the right is a wetland that I was involved in bringing back from the brink of obscurity. Lots of complaints. Avian botulism, odor complaints, algae, lots of things going wrong with it, but we brought it all back, and it's now a fantastic asset, and the community's praising council for their efforts. Photo on the left is a very over-engineered bio system in its own jail, if you like. Got to have a laugh about that one. I consider that an eyesore and a distraction. I don't consider that increasing property values. That's having the opposite effect. The wetland on the right also has its own issues, of course. No pre-treatment. Look at it. Bio on the left, the OSD maxi mesh has come off at the back. It's hard to access, hard to maintain. There's not proper vegetative cover. Again, just a box in the landscape, particularly ugly. On the right is a wetland I was involved with years ago. No circulation, no pre-treatment. It got isolated, became stagnant, bloomed. Neither technique is foolproof, is what I'm saying here. They all take a bit of knowledge in the design and then back that up with a ton of maintenance. Okay, so what you need to know, you need to get a good consultant that understands secondary treatment to assist you with designs if you're a council. There are multiple design parameters. It's not just flow rate. It's not just plug it into music, ta-da, there we go. Bio tends to work best for developers, wetlands for councils. And just because music says it so does not make it so. There's no right or wrong answer. Both techniques have their strengths. And we'll talk more about bio when we do this thing with Brad in Western Sydney in August. But I have to say, massive fan of wetlands. However, those two are not your only two options. Let's talk media filters for a sec. The Stormfilter product was huge in the USA back in the 1990s. It's got bigger and better ever since. It's certainly the #1 media control system around the world. Basically, flow comes in, goes up inside a hood and goes horizontally through a porous shroud, if you like, a screen that holds the media in, flows through into a central collection thing, and out it goes at the bottom. I've had experience with them. I like them as a product. Basically, you can change the media to customize it for whatever pollutant you're targeting. Tried, tested, reliable, high performance. It treats low flow rates, but it's designed to treat low flow rates. But of all of the media systems, I think it's probably the easiest to clean. The cleaning frequency might be 2 days. if you've got a high silt load coming straight in during construction, or it might be 5 years if you've got very nice clean roof water and other things coming in. The cleaning frequency is very site specific. The photo on the right is sort of the schematic from Ocean Protect about the internals of that particular product. I'm not going to run into it, but you can sort of see there's a shroud over the top, and the flow can go up and then goes horizontally into the middle, gets treated and drains out. It's a very good product, but it's not the only product. There are other media filters. So those of you doing design in this space, do your research. This is not a one-off endorsement. You have to use this product. I've used it in the past successfully. I like it, but there are other alternatives. Have a look around. But my recommendation would be to focus on the ease of cleaning. These systems where I found them not working, it's because they've had poor access, roofs too low, can't get in there. If you've got good access for cleaning, you'll go a long way to getting the outcomes you're after. If we look at filters and flow and how these things work, porous pavers, basically the flow is going down through them. They are another form of secondary treatment as per sand filters. The problem, of course, is as the flow goes down, pollution blocks on the top and cuts it off and sends it into bypass. The media filter, so your storm filter, would fit into this second category in the middle, where flow goes through the media or the membrane from the side. The jellyfish by Ocean Protect would be another one where the flow's going through the membrane on the sides. Then you have the media filter and upflow filters, etc., where the flow goes up through the base. It comes in low, goes up through it, with the theory that pollution will drop off. Unfortunately, that's not always the case when you take into account emulsified oils, vegetable gums, paint, slime, moss. It just blocks it and it stays blocked. So you end up with very high maintenance. And again, the major thing that you guys need to look at here is surface area, the area that allows the water to get into your media. My experience has been the more area in your cylindrical ones will give you a better outcome. So this is just a picture of a porous paver on the left. Of course, as it starts blocking with sand and silt and algae and moss and slime and things, that porosity drops dramatically. When you go to clean it, you jet it with a high pressure jet, which pushes some of the pollution further in and blasts some of it off. So not a massive fan of porous pavers. I have seen them work well in some instances, but I've seen them failed in many more. The center photo there is of the storm filter cartridge system. So you can see the white media inside some of those cartridges. And that's just been, those have been taken out of a device. They've been emptied into the suction truck and refilled with new media. You can see their little hood cartridges that go back on top before they go back in. But one man was able to disconnect it and lift those things out. On the right-hand side is a hydroflow system, a hydro filter, sorry, where it's just one big, you might as well call it a porous paver, and the flow has to go up through it. Blocks very quickly, ultra high maintenance, very unreliable, not a big fan. Okay, then we come to ultra fine screening. There are some products out there at the moment with screens in them like 100 microns or less. The problem is, you know, as soon as you get the things that normally block them, they block them really, really fast. So they're claiming very high performances, but as soon as you get biofilms and hydrocarbons and stuff coming in, they'll block. And so their treatable flow rate will decay, and they're not nearly as reliable as some of the other techniques. Potentially high maintenance cost too to keep unblocking these screens. Okay, this is one such device where I was out there with the cleaning contractors. The sediment in the bottom is because it's a sump. Sediment will drop out wherever it hits a sump. The sediment wasn't screened, it just sank and settled. The screens themselves, though, there was sediment behind the screens which dropped out during bypass, and when we hit it with a high pressure hose, it just tore the thing right open. So structural integrity, not great. Reliability, nah, hard to clean. Jury's out on ultrafine screening. We'll see what comes up what the industry comes up with moving forward. Okay. Couple of quick things you want to take into account when you're looking at which technology and sizing them. Certainly there they are, your catchment area, the target pollutants that are appropriate for your receiving waters, what the approval authority is requiring of you, hydraulic impacts. Number one, don't flood anyone. Number two, get the hydraulics right. Then you want to have enough storage in it to have affordable maintenance. And then don't forget the access for your cleaning vehicle that's going to have to come in and do it. You can't obviously bypass work health and safety for both the cleaners and the community. You also need to take into account the land area available and the geography. If you've got a big steep site or you've got a big long flat site, you're probably looking at different techniques. Who owns the land and then what's in the land? Lots of things to take into account when you're sizing these. I'm going to jump through this one very quickly and just sort of say the common requirement from a lot of councils is that they're requiring you to remove 90% gross pollution, 80% TSS, 45% TP, your total phosphorus, and 45% TN. My question would be, why? And the answer is you should be looking at what is impacting the waterway health of your receiving waters. Typically, if you're fresh waters, phosphorus is going to be governing whether you're getting algal blooms or not. In coastal tidal areas where it might be nitrogen limited, it's also flushed and removed, and you've got a lot less things to worry about. So my big question is, why are we spending so much money targeting nitrogen? Discussion for another time. But if you do magically trap nitrogen and you can remove it from the system, so let's say you do magically remove 45% TN and then you put the water back into your downstream creek, what do you think happens? Well, it was at a natural equilibrium when it came in. You took out 45% of nitrogen. It goes out. It wants to get back to natural equilibrium. It goes, where will I get nitrogen from? So if you can magically strip out 45% TN, nature will put it back in. Everyone follow me. Take a nice deep breath. 79% of what you breathed in was nitrogen. No shortage of that going around. Okay. What other pollutants should you target? There's a couple on there. There's rising expectations, specifically in regards to chemicals, fertilizers, and certainly these days, microplastics and PFAS. So I'm very keen to see how the industry evolves to target those devices. All right. We're going to, I won't run through all these take-home messages, etc. You'll be able to have a look at them later because we've covered it all during the presentation today. But obviously there's poor, medium and high performing proprietary devices, and there are good and bad wetlands, etc. All you can do is use knowledgeable, experienced people. And at the end of the day, there's some good advice in the yellow book that looks at the maintenance of these things. Don't flood anyone. But the biggest dot point at the bottom of the list there is nothing works without maintenance, and you need to consider designing for ease of long-term maintenance as one of the key parameters for any form of secondary treatment. Thank you very much.
Thank you, Murray. A take-home message from you is always a long drive. And look, thanks so much for sharing all your expertise and knowledge. And I'm sure everyone's got at least something, if not lots and lots of things out of that. So thanks for sharing those. And the questions are rolling in. So Sean Quilty agrees, Sean, from Director of Quilty Engineering Hub.
Sean.
I know, he's a legend, right?
Yeah.
Question, Sean actually posed the question to the councils. So if you're a council staff member, maybe feel free to respond in the chat. But a question from Sean is, are there any councils looking to implement regional wetlands instead of at-source bioretention? So yeah, Sean's asking, is there any councils looking to implement regional wetlands instead of at-source bioretention? Also, pre-treatment, acceptance of proprietary products as council assets, e.g. GPTs. I'm not sure if you want to share some of your insight on that one, Murray.
Well, certainly I'm a massive fan of a high-performance GPT in front of a wetland. I ran a seminar in at the Sydney Olympic Park years ago called GPTs and Wetlands, Perfect Partners. If you've got a high-performance device that's stripping out the load, that allows the wetland to do what it's supposed to. A lot of councils have historically shied away from accepting GPTs and stuff. They try and get everything back on lot and leave it with the private sector. and what you and I, Brad, would know, and Sean, of course, is that a lot of stuff in private ownership, they see it as a cost with no benefit to them, therefore it doesn't get maintained. I'm a massive fan of having your primary treatment and your secondary treatment in council ownership, because their job is not to make a profit. Their job is to look after the environment and the community. And as a result, they are a far better carrier to do that task. Are they perfect? No. Are they budget limited? Yes. Do I like regional schemes instead of outsource? Hell yes. Why would you put in 20 GPTs when you can put in, 2 or 3, and then have everything regionally and strategically? Ideally, high performance GPT, nice wetland to couple it up, and then, hey, let's add on stormwater harvesting for good measure and introduce some water sustainability. I think councils are starting to realise that as their number of GPTs and outsource controls are, becoming hundreds, they're realising they don't have the maintenance budgets to afford to maintain them. And if you don't maintain them, they'll stop working and you've wasted all the money. So I think if you've got fewer devices that are regional and strategic, you're on the right path.
Yeah, and out of interest, like Alan Walker from Kingsbury Council's just put in as
Oh,
well. Bio needs primary treatment. It's disastrous without. And this is something I've seen for 20 years. If music says it's okay, it seems to get the tick of approval. But we see so many assets like Bioretention, Wetlands in particular, that really struggle due to the lack of pre-treatment or outsource pollution reduction. It's just, for me, it should be the standard approach, not the exception. As in, if you're putting in regional wetlands or end-of-pipe wetlands bio, it must have some sort of GPT. Now, I'll be criticised in that regard because, Brad, you're just trying to sell GPTs. Well,
no.
Sure, but the likes of Murray and others, and there's obviously a bunch of companies that can provide a GPT. So,
look, I've designed them, I've sold them, I've built them, I've audited them, I've cleaned them, and I've decommissioned them. And a good GPT will be an absolute asset for councils moving forward to protect their secondary infrastructure. I really hate seeing wetlands go in without them. And bio, of course, everything's sort of higher up with bio as opposed to wetlands that could be further down. So it just makes everything just a little bit harder. So Alan's completely right. You definitely want to pre-treat your bio, and whether that's with pit baskets or GPTs or swales or other methods, there are a lot of ways to do it, but please do it.
Yeah, so it's certainly a lot easier to clean out a GPT than it is a wetland. And that leads me to the next question. And sorry, just to follow up, so Kylie from Mackay Council says, Sean, to answer your question, they are putting in a regional wetland. So if you're keen to see some examples, maybe have a chat to Kylie. Greetings to Mackay, Kylie. Thanks for joining. From Mackay to Stirling in WA, it shows you the reach of this webinar format. Rebecca Thomas from Stirling Council in WA asks, is dredging a constructed wetland recommended? We have a system which is decades old, in brackets, no maintenance, and there are water quality issues being added by birds, etc. So would you recommend, Murray, dredging ever a constructed wetland?
Yeah, look, it becomes a can of worms, because that wetland will now have all sorts of flora and fauna living in it, etc. You might need to do an REF, a review of environmental factors. When you pump the water down, where does it go? How do you treat it, etc.? And then all the sludge and stuff that's in the bottom, how do you get it out? Interestingly, Optimal Stormwater has just been doing some work with Wyndham down in Melbourne, dewatering a couple of their big wetlands, and we're taking out hundreds of tons of sediment and stuff that's built up in them. I really don't like doing it. It's great to design a wetland that's got a sediment forebay at the front, so you can just isolate that and clean the front 10%. But historical wetlands, it's just one huge system, and there's really no way around it. So it costs an arm and a leg. It's difficult to dewater, and you really want to avoid doing it by designing proper pre-treatment with a nice high performance GPT. So for Stirling in WA, I'd be putting in a high performance GPT and looking at how you can bypass the water while you're doing the cleaning. But unfortunately, you're either doing it with an excavator, or you're doing it with suction pumps, or you're doing it very expensively with a suction truck and a hose and a tanker it away. There are a couple of ways to do it. . My details are on the screen. Happy to give you some advice. Flick me an email.
Which brings me to another problem, Murray, that I'm hoping you might be able to solve, because I've got two questions here and they're kind of the same. So Anthony Healy, Anthony's from Eclipse Consulting Engineers in Norwest and New South Wales. He says, councils like Mid Coast Council do not accept proprietary treatment devices. How can we achieve pre-treatment upstream of bioretention in these cases? And a second question, more or less the same, from Jackson McKernan, asks, when you have a client, e.g. state government or local council, which is resistant to using GPTs, how do you suggest you open the dialogue on using GPTs on projects?
Ooh, yeah, hard. I wasn't aware that was the position of Midcoast. We've just finished decommissioning a Barramy and building a new stainless steel graduated offline trash rack for them, and I know they have multiple proprietary devices. If they may have changed their policy, I wasn't aware of that. I would think that if council is looking to get high performance out of their secondary treatment, you can't do it without pre-treatment, and you're always better off with a proprietary device that's been tried and tested, and it's cost effective to manufacture, as opposed to a one-off consultant designed, maybe it'll work solution. So happy to have a chat with the people at Midcoast and find out what's happening there. State government, yeah, they just don't want the maintenance bill associated with GPTs. They want the environmental outcomes, but they're not prepared to pay for either the capital or the ongoing maintenance. I think has been the historical issue. So I don't know how we get around that. We need to make sure they're part of our environmental community and they're chipping in and keeping our environment clean. It shouldn't just be all left up to councils. The other stakeholders, the state government bodies, some of them have done a great job. Some of them are doing a good job now, but haven't in the past. And some of them just still got their head in the sand. Sorry.
But Mid-Coast Council aside, I have seen this in other councils. Councils just flatly will not accept proprietary devices, even GPTs. So to Jackson's question, how would you suggest opening that sort of dialogue to propose GPTs where it might be handed over to council?
It's a difficult one. It depends on why council actually has that opinion. And again, there's my email. Flick me an email. I'm happy to help you out and speak to the council involved and find out the basis on which they're suggesting that is actually a good solution. Is it they want solutions that are not proprietary, or they just don't want pre-treatment? And if they don't want pre-treatment, that's fine. You just have to have the huge costs of dredging and environmentally destroying your wetlands, every 20 years to try and clean them out, because your wetland is functioning as the GPT. And as you mentioned, Brad, cleaning a GPT is going to be 2% of the cost of cleaning a wetland. So why wouldn't you put in technology to achieve something that's practical and cost effective and keeps your wetland looking good, year round? So
I think that opinion's often held because it's considered another asset. B, music says you don't need it. And C, I think there's a delusion that people think stormwater is actually clean and doesn't have litter. I think pick of those three, I think it's probably the key reason why sometimes the rule will be no GPTs. I see this in Victoria in particular, large regional scale wetlands without pre-treatment, and you're having to dig them up. And it's always a bit of a funny thing for me, because these are often used to, as you've indicated, to attract wildlife. But I'm very of the opinion that these systems, wetlands in particular, I know you're a fan, Murray, and I am too, but when they're done right, and when they don't have pre-treatment in particular, they definitely become ecological traps. So wildlife is attracted to these environments, but they actually suffer poor health as a result of that, unknowingly.
Well said.
Anyway, question from Rashad Razan, who wins the award for best name today. Rashad says, you mentioned, Murray, about outlet inverts for a basin being at the base level is not a good thing. Would you have any suggestions as to how to decide this? Would you go with a 1 in 5 year level for that basin, for example?
Oh, no, very simple. If you have a pipe coming out and your overflow level from your bio, you want that matching the invert of your pipe. So ideally, pipe comes out, drops 300 mils, and you've got 300 mils of area for the water to build up and infiltrate before it overflows. What you don't want to do is have the bio putting the backwater onto your GPT. So there's no magic number. If you've got 400, 500 worth of extended detention in your bio, that's great. But don't put the biosurface at the same level as the pipe coming out. It builds up and causes you all sorts of problems back upstream.
Alan Walker from Kingsborough is never short of a few words. He's added a couple of comments. Yeah, he thinks often they don't have pre-treatment because lack of funding, lack of understanding of their purpose, and also other community demands on funds. So Alan giving the local government perspective from Kingsborough Council.
Yeah, I think one of the other reasons, Brad, down in Victoria, it's gone down that path, is the focus from Melbourne Water back in the 90s and early 2000s was very much about nitrogen. That was the primary driver, and GPTs don't trap nitrogen. And music says your wetland will trap 100% of gross pollutants, so why do you need them? What we've learned over the past 30 years, though, is if you want your wetland to survive and thrive, you've got to take out the load, especially of the organics that get in and break down and create anaerobic breakdown and all the consequential problems.
Yeah, Rob Booker from Sunshine Coast Council, thanks for chiming in, Rob. Rob makes a really good point. He also thinks the way pre-treatment is actually modelled in music is sometimes an issue. It is, and he says it is used as a way to reduce the bioretention area or wetland area. And actually, I'm not sure if you're aware of this, Murray, you obviously know that there's been some SCUDEP approval for a GPT that has extremely high rates of nutrient removal. And in fact, if you just use that device, you don't need any bioretention wetland. But that aside, I actually do really like the Sunshine Coast Council policy that basically says, irrespective of data, SCUDEP approvals, whatever, if you have a GPT, like an end-of-line CDS style device, you have to model nutrient removal as zero, regardless. So that basically means, yeah, recognise that pre-treatment is really good and it does remove gross pollutants and solids, possibly, but you still that shouldn't impact the size of your wetland or bioretention system. So fundamentally, I think you can't assume any nutrients or I think solids for these end-of-line GPTs, which I think is something that all councils should actually look at. Rob, you're welcome to provide some further comments as well. And I could see there's more comments coming through. Murray, whilst you're a great conversationalist, a lot of people chime in and want to contribute as well. But and Jude Wajasiria, and I'm sure I mispronounced that. Sorry, Jude. They say, given that a wetland was originally specified for stormwater treatment in this location, could council clarify whether a GPT would be considered an acceptable alternative, and under what conditions it might what conditions it might meet equivalent water quality, flow attenuation, and biodiversity objectives? Does that make sense, Murray? So
yeah, a GPT has no biodiversity, no ability to strip out nutrients and solubles, etc. They're mutually exclusive. A GPT is primary treatment, your wetland is secondary treatment. You can't swap one for the other.
Cool. Look, great points. And if people want to learn more about wetlands, GPT, or anything else under the sun, fashion, you've got his contact details there. And just a reminder, folks, if you do want to see the recording or you missed it, I know quite a few people have messaged me now saying they arrived late, they can't get enough of Murray. We'll have a recording. I might just share my screen very quickly if that's okay, Murray. Just give me a sec.
That's right. And on the slides, I've actually put in a fair bit of text so you can look at it later and it does make sense, as opposed to lots of photos where you have to have the recording for you to know what you're looking at.
Yeah, and we'll have those slides available on that website link there. So if the slides and recording will be made available on this website here. And just as I mentioned before, the CPD forms will be made available in a week or so. If they don't come through, please let us know. Just email that email address on the screen. But the key thing is, thank you so much for Murray Powell for joining us today and sharing his pearls of wisdom.
Pleasure as usual, Brad.
Thank you also to everyone who's dialed in. Much appreciated. A reminder, folks, if you love a good webinar, who doesn't? The next one we've got is in 23rd of July, all about high flow bioretention. So please feel free to join to that. And if you're keen to register, you just got to go to that website that you can see there on the link. But again, big thanks to Murray for giving up his time. Big thanks for everyone for dialing in, and look forward to seeing everyone in person sometime very soon.
All righty. Bye now.
Thank you, Murray.